Good Lord, ride all the way. A 10.
9,
8,
7,
6,
5,
4, 3, 2.
1.
Hi everybody, and welcome Slooh members and Astronomy Magazine readers. So glad you could join us for this latest live Slooh show. So why in the world are we here looking at some of the latest images coming in from Slooh of the planet Jupiter? Well, this is the 4th of July. It's a day when Americans are celebrating their stuff, fireworks in the sky, cooking hot dogs. But there's also something going on in space right now that's pretty important, a pretty marking event. And this is that the spacecraft Juno is arriving today, July 4th, 2016, at Jupiter. And it's been quite a long journey for this spacecraft. In August of 2011, that's when it launched, right about 5 years ago, came in with an Atlas V rocket at Cape Canaveral in Florida. But even though it launched at that time, it stayed in the inner solar system for quite a while, wasn't venturing out and seeing Jupiter just yet. About 2 years after that, it pumped back over to Earth. October 2013, there was another close approach of Juno to the planet Earth. We're actually Slooh members. They saw this happening. They were able to see what was going on because, yeah, we're actually seeing that on our screen as we speak. So it was going close to planet Earth, and as it did so, with the telescopes, Slooh members did track it, and it's that streak going across sort of the bottom right of the screen there. And why it came back, why this telescope or the spacecraft returned, is because it wanted to get a gravitational assist. It wanted to use Earth's gravity to speed up so it could get to Jupiter a little quicker. And so after 2013, it sped along for a couple years, and now we're back to July 4th, 2016. Where it's been speeding up for quite a while, and now it's gotten to about 150,000 miles per hour. And so if we left it like this, it would just zip right on by Jupiter. But what's going to happen tonight is it's going to dig its feet into the proverbial soil, as it will. It's going to make a braking maneuver, slow down, because right now it's going about 275 times the speed of a Boeing 737. So we really need to slow this one down to get it so that it will safely get into the orbit of Jupiter, where it can do some really fascinating science. So what are we expecting to learn from this spacecraft, the successor to the Galileo spacecraft that flew around Jupiter for quite a while earlier on? So we're expecting to learn a lot of things about Jupiter, because even though we know a lot about this planet, there is still so much more that needs to be discovered. Different things about what percentages of elements compose parts of its atmosphere. What lies exactly below that thick layer of clouds? We can see that magnificent atmosphere, but there's so much more beneath the surface. And then, of course, since this planet is so gigantic, so active, we want to learn more about its gravitational field and its magnetosphere as well. And all these things will maybe tell us a little bit about ourselves and the origin of our very own solar system. So there's a lot that's going to happen in the about 2 years that this spacecraft is expected to orbit Jupiter. There's so much to learn, and today is the day that we're getting started. And so to help us sort of understand this journey, we have a bunch of fun guests that are going to be joining us this evening. One of them being the beloved Slooh astronomer Bob Berman, who's going to be telling us a little bit about the bundle of knowledge that we already have of Jupiter, what we know getting up to this point. And then Tricia Ennis, the producer for the Slooh shows, is going to pop in and let us know a bit about the mythology behind Jupiter and also Juno. Juno and Jupiter are very strongly intertwined mythological figures, and there's quite a fun story about that just coming up. And then after that, I'm going to be joined by John Wentz, the associate editor for Astronomy Magazine, and we're going to be talking about the future of this mission. Now that it's here, what can we expect? What exciting things might be coming just around the corner? And of course, along with these guests, we also have a press conference that's going on at NASA headquarters right now. And if ever there's going to be an exciting thing that pops up in that press conference, some interesting announcement, we might head over to that live in this program here, so you won't miss out on any of the breaking details that might be happening in this spacecraft's arrival to Jupiter. But with that all being said, this is a fun show here tonight. Let's get started. So the Juno mission has been in operation for just about 5 years now. But at the same time, we've been looking up at that planet for much longer than that. Even before Galileo was looking at Jupiter and its moons in his telescope, we were looking at this planet in our sky for many, many years. And so just to get an idea of where we've come when it comes to this planet, what we know, the body of knowledge that we have amassed. We're going to be talking today with Slooh astronomer and Astronomy Magazine columnist, Bob Berman. So thank you very much, Bob, for joining us here on the show tonight.
Pleasure, Eric. A very historic moment, so it's an honor to be here.
Oh yeah, it's really great to have you here. And just to help us understand like where we're coming from when we're sending the spacecraft up here, one of the main things people think about maybe when they look at Jupiter is the incredible atmosphere that does surround it, all of the action that's going on there. And so as we've been able to look at that part of Jupiter, and we're seeing that through the view here, what do we know, I mean, in terms of the basics about the atmosphere? Maybe what mysteries remain that could maybe be discovered during this mission?
Well, big, of course, comes to mind. Everything is big. The atmosphere is big. You're talking about a body that has 318 times the weight of Earth, so large that 1,100 Earths could fit inside. Let's repeat that. If it were hollow, like a mayonnaise jar, and you started pouring Earths inside, over 1,000 planet Earths. So it's big, and with that kind of mass, it can hold on to an atmosphere. In fact, in a way, it's all atmosphere. You know, it's hydrogen and helium mostly, the same stuff the sun and the stars are made of. But as you go down further and further, it gets thicker and thicker and thicker. And does the hydrogen ever end? Probably not. Maybe there's a small rocky core. One of the things that Juno may help us solve with one of its instruments. But other than that, as I silence this phone, other than that, the whole idea is that it's got an atmosphere like the sun, but it's also got parts that are very un-sun-like. That is methane, ammonia, some carbon, some nitrogen. And it's those minor components that really have us more excited than the major ones. This is the BBC calling. I'll be doing a show with them a little bit later on. And so that hopefully will be one of the big mysteries that Juno is going to help us with. The lesser components, which is, after all, the stuff that our planet and our bodies are made of.
Right, and so it's all these small parts make up this really incredible planet. And speaking of just unique parts, one of the most interesting things that a lot of people think of when they think of Jupiter is that great red spot. And could you maybe tell us a little bit about what that is?
Well, we know it's a storm, and it's like, and it floats above the rest of the planet. When we get really good nights and Slooh members image the red spot, we see it for what it is, a giant oval 2 to 3 times the size of Earth, floating 50 miles, there it is, 50 miles above the rest of Jupiter, like a floating city. And it revolves, it's a storm, so it spins just like a giant cyclonic hurricane, spins around in about once a week. The weird thing is that it's been around 4 centuries. It's been observed since the earliest days of telescopes that were big enough to see it. We're talking about the 17th century going into the 18th century. And but a basic question is, why is it a red spot? What gives it the red color? I asked Carolyn Porco, an expert on Jupiter some years back, and she had a very interesting answer, Eric. She said, we have no idea. Imagine that. I mean, the basic child's question about the red spot, why is it red? And science still has no idea. Is it a sulfur compound? Is it phosphine gas, which is a combination of phosphorus and hydrogen, very flammable gas? We really don't know. And that's another question that perhaps the Juno mission will be able to solve. What the heck the red spot is made of that makes it red?
Right. And just to reiterate, we're looking live, or as live as we can, really, with these Slooh images that we have. So Jupiter just actually set very recently when it came to our perspective with the Chile telescopes. But we're looking at the latest images that we were able to get from Chile before that planet set in our view. But we do have telescopes in different locations, so we can get as close to that live as possible whenever we can. And here it is, right in those scopes. And so we see so much of the atmosphere, and that is so much a part of what we know of. And you touched on this a little bit, Bob. We're talking about sort of it's made primarily of that hydrogen and helium gaseous material. And do you have any thoughts on the possibility of like a solid core or not in the center of Jupiter? Do you think that's likely? And what would it mean if there was one?
Well, it's probably likely simply because when you get down to the tremendous pressures that exist in the core, hydrogen itself can act like a metal and become solid. So even if there is not a rocky core the way Earth has, we have a little ball about the size of the poor demoted planet Pluto that is about 1,400 miles in diameter, solid, not liquid, in the core of Earth. Is there something similar in the middle of Jupiter, or is it merely hydrogen crushed so densely that it's acting like, well, I was going to say acting like a core. No, it would be a core, but is it merely hydrogen, or there's something other stuff there? And we may be able to solve that with this mission, believe it or not.
Right, and this mission is coming very close now, and it's in a really interesting position right now, the Juno spacecraft in its arrival to Jupiter. With the speed that it's going, how fast it needs to slow down, this is when a lot of fuel is going to be expended. And I mean, is it just me, or does this seem like this might be the precarious point where it's a little bit of a make it or break it position? Like, are there certain things that might...
It definitely is, because it's coming in at about 40 miles per second. I think we can all picture that. And it has to be slowed down by about, just lose about 1,000 miles an hour, which isn't a terrible amount. But while it's doing so, number one, the solar panels. And what is it doing with solar panels? We've always had plutonium supplying electricity on all previous spacecraft beyond Mars. And so this is the most eco-friendly, greenest spacecraft ever, thanks actually partially to solar technology improving so much that instead of using plutonium, we actually have solar panels. The sun is only 4% as strong out there as it is here. So it's pretty cool that we can use that. The question is, the solar panels won't be able to point toward the sun during this insertion maneuver. Will it be successful enough so that the spacecraft can reorient itself and pick up the badly needed electricity so that the batteries don't run out? And also, this is a swoop through tremendous radiation. You and I get about 1/3 of a sievert of a radiation per year, just naturally. And this spacecraft is going to pick up 20 million sieverts. I mean, we get 1/3 of a sievert. This is getting 20 million sieverts. So whether the electronics and the rest of the craft are really going to get seriously fried, or whether they've been successfully built to withstand it, is another big question. Adds to the excitement, really.
Absolutely. And you just touched on this a bit here. There's such an impressive amount of gravity and just a magnetic field that we're going to have to deal with this spacecraft when it's going to be entering into the regions of Jupiter. And so what do we sort of know going into this mission about the gravity and the magnetic field that we have that surrounds Jupiter?
Well, Eric, we've got the fiercest magnetic field and the largest in the solar system. What's interesting is, even though Jupiter is 5 times farther from the sun than we are, in other words, it looks much smaller than the sun, which is why we need the Slooh telescopes or any telescope to see it as a disk. If we could see its magnetic field, it would be larger than the sun appears in our sky. That's how huge its magnetosphere is. And this fierce magnetism captures subatomic particles, mostly from Io, that innermost moon, which is throwing, if I remember right, 50 tons of material, mostly sulfur and some sodium, into space per second. And I may have misremembered that. It may be 1 ton per second, but I think it's 50 tons per second. But in any case, all of this is captured, ionized, captured, and remains there around Jupiter to present a hazard, lethal hazard, to anyone who gets too close to Jupiter. So these are the dragons that are guarding Jupiter. You'd get more radiation than you would from going within the center of a nuclear power plant. And so this spacecraft is by far going to be the closest into Jupiter. It'll skim during its 37 orbits around Jupiter. At its far point, okay, that'll be safe. But at its near point, it'll only be about 2,600 miles above those cloud tops, which is nothing at all. And it'll be deep within the radiation belt. So we'll see whether it can survive, really. It's supposed to.
And so there's so much going on here, and there's so much to learn about. Like, we know so much about this planet, but there are still some mysteries that are surrounding it, and this spacecraft will really maybe help us along with that. Whatever does end up happening, that'll be another step forward in terms of our knowledge about this planet. And thank you so much, Bob, for joining me here tonight to maybe tell me a little bit more about where we've come so far.
Oh, it's a pleasure. It's a very exciting night, Eric. Thank you.
Thank you. And so that was Slooh astronomer and Astronomy Magazine columnist Bob Berman. And you can catch Bob actually twice a week here on Slooh, Tuesdays and Thursdays at 6 p.m. Eastern Time. He tells us about different tours of the universe for a full hour, so quite a lot of fun. But now we're going to take a short commercial break, but coming up next, we'll be taking a quick break from the science of Jupiter, going a little bit more into the stories about this planet and the mythological figures who lend their names to the planet and the spacecraft that is visiting it. And in just a few moments, we'll be speaking with John Wentz from Astronomy Magazine about the future of the Juno mission and some of the fascinating things we hope to discover over the next couple of years. So thank you very much for joining us here. And also, to our new viewers that are tonight joining us from Astronomy Magazine, if you're enjoying what you're seeing, I would highly encourage you to become a member of the Slooh community. It's absolutely free to try, and there is no obligation. So at its core, members control our robotic telescopes here in the Canary Islands and Chile via a simple but powerful interface to see all that glows in space. In fact, Slooh members have taken well over 4 million photos of over 50,000 different objects in the sky. So Slooh works like a jukebox. One member controls the telescope while other members get to see what the telescope is viewing live, while everyone contributes to an ongoing conversation. We always say it's like cavemen and women gathered around the campfire. We wonder about the universe and share our great diversity of perspectives. So it really is space for everyone here. So please do give it a try, and in the process, you'll be supporting our ability to make programs like this available to the public. So with that being said, thank you again for joining us, and we'll be right back.
Welcome back to our broadcast celebrating the arrival of NASA's Juno spacecraft at the gas giant Jupiter. My name is Trisha Ennis. I'm the resident mythology expert here at Slooh, and I've been patiently awaiting the chance to tell this particular story because, as a woman, it gives me a slightly sick pleasure. Now, I've told a number of these mythological stories about Jupiter and how it was named for the king of the gods, known as Jupiter to the Romans and as Zeus to the Greeks. Now, Jupiter/Zeus was married to Juno, known to the Greeks as Hera. So the name of the spacecraft is quite fitting. The name becomes even more fitting the more you know, but we'll get there soon. First, you should know a little more about Juno and Jupiter. For the sake of clarity, we're going to discuss them using their Greek names, Zeus and Hera, since those were the ones they had when the stories were first written. Now, Hera was the goddess of marriage and childbirth, a patron of women, and could have not been more badly matched with her husband. Zeus was power-hungry and arrogant and known for his many affairs with gods and mythological spirits and mortals alike. He was pretty indiscriminatory when it came to his many dalliances, and a large number of them resulted in children, many of whom became famous heroes, like Hercules and Perseus, and one half of the Gemini twins, Castor and Pollux, among a lot of others. Hera, being the goddess of matrimony and endlessly faithful to her equally unfaithful husband, was filled with rage and jealousy, not just against her husband, but also his mistresses and his children. She developed a reputation for taking out that rage against them. In numerous cases, when Hera discovered that her husband had impregnated another woman, she would punish that woman or the child. In the case of Leto, the mother of the twin gods Apollo and Artemis, she banished the woman from giving birth on terra firma, the mainland. Poseidon, the god of the sea, took pity on Leto and guided her to the floating island of Delos, where she was actually able to give birth to the twins, which is why they were able to exist. The birth of Dionysus is still more dramatic and varied. There are a number of versions of this story, each with its own depiction of the horrors thrust upon the baby god at his own birth. In one version of the story, Hera discovers that his mother, Semele, is pregnant by Zeus, disguises herself as Semele's nursemaid, and convinces the woman to demand that Zeus show himself in his true form. Mortals can't look at the Olympian gods in their true forms. It's too much for our tiny brains to handle. So when Zeus showed himself to her in his true form, Semele was destroyed. Zeus, though, was able to take her unborn child and carry him to term in his own thigh, because gods couldn't do that. In another version, Dionysus is born without incident, but Hera sends the Titans to rip the infant apart. Zeus is able to rescue only his heart, which he places inside Semele to grow a new Dionysus, making him the twice-born god. But it's the relationship between Hera and Hercules that is probably the most well-known and the most tragic. Many people, likely due in part to Disney, wrongly believe that Hera was the mother of Hercules, but Hercules was a demigod, meaning that he was half god, half mortal. Zeus was his father, but his mother was Alcmene. I'm not great with Greek names. She was the wife of a man named Amphitryon. Hera, naturally, hated Hercules because he was the son of her husband through another woman. And she tried to kill him almost immediately by sending 2 serpents to kill him in his cradle. Hercules, because he was a demigod, he had supernatural abilities, in this case supernatural strength and agility. So the story goes that he throttled each of the snakes and killed them in each of his tiny baby hands. And he was found in the morning playing with them like children's toys. Later in his life, after he'd grown, gotten married, and had children, Hera drove the mighty Hercules mad, causing him to kill his wife Megara and their 6 children. When he woke from his madness, Hercules realized what he'd done. He was overcome with sadness, and he sought to make up for his actions, which sent him on this mission to his cousin Eurystheus, who was a king, can't remember where, who sent him to complete 12 labors, which became the 12 labors of Hercules, which is one of the things that made him a famous hero. But Hera, over the course of those 12 labors, sought to make those labors ever more difficult as they progressed. Now, these are only some of the stories of Hera and her interactions with Zeus's many different affairs. There are a lot more, including the tales of Echo and Io and countless others, not to mention what happens when you simply anger Hera without sleeping with her husband. Talk to the Trojans about that one. So what does this have to do with a spacecraft on its way to orbit the planet Jupiter? Well, we already established that the craft is named for the goddess of matrimony, and the planet is named for her philandering husband. But what about Jupiter's seemingly endless number of moons? Well, each of those is named for the seemingly endless affairs the king of the gods had behind his wife's back. So it looks like, once again, Juno is checking in on her husband and his many, many friends. Eric, back to you.
Thanks, Trisha. And so, yes, that was Trisha Ennis, a Slooh producer and sort of the shadow behind all the shows here. Thank you very much for that enlightening segment. So Hera and Zeus, or Juno and Jupiter, they have a very close relationship. And so, scientists, it's not all about the math. Sometimes it's about the stories that we bring to these objects. So there is that human element that has carried that spacecraft toward Jupiter. And so we've talked a little bit about Jupiter of the past, but this mission is all about what we're going to figure out about Jupiter going forward. And so today is that day that Juno begins its orbital shenanigans around Jupiter, and that slowly over the course of a couple years, very interesting things may potentially be uncovered. And so during its time around the planet, Juno will make observation of Jupiter's atmosphere, magnetosphere, and deep inner composition. Lots of things to maybe find out. And so my next guest has been excitedly following along with the Juno mission, just like the rest of us. John Wentz is an associate editor for the Astronomy magazine. And John, thank you very much for joining us here on the show today.
Well, yeah, thank you very much for having me. I'm happy to be on here.
It's great to have more thoughts about the potential involved in this mission here. There's a lot of things that are going to be going on in terms of learning about the composition, the magnetic field. And when we're learning about all this stuff, do you think that there might be the possibility we might find any game-changing discoveries out there? Or is there a discovery that you might be hoping that we might make as we learn more about this planet?
Honestly, I think this entire mission is going to be pretty game-changing for our understanding of Jupiter, because we're finally going to understand a lot of the things that to this point have been theoreticals, where we've not necessarily known exactly what's going on in the atmosphere. We've not exactly known what's going on in the radiation belts and in the magnetic belts. We're going to start having a lot more answers than questions and computer modeling regarding this.
Right, exactly. One of the things that fascinates me in particular is how much water or oxygen that we'll find in this planet might be really interesting in terms of figuring out where it's formed in our solar system. If it was formed further out and it migrated inward, it can just tell us a little bit more about the origin of where this planet might have come from. And since there's so much that we could possibly be learning here, do you think that 2 years is enough time for this mission? Maybe we need to send out a sequel. Do you think that we could be having a Juno 2 or a Galileo the sequel?
I think that NASA always builds to incremental approaches in how they approach the exploration of bodies. It's the flybys, then it's the orbiters, then it's the kind of more dedicated in-depth studies. So I wouldn't be surprised if there are follow-ups that's somewhere in between a Juno and a Galileo, in which it's both studying Jupiter in depth, but also it has 4 quite fascinating moons, 2 of which are potentially habitable. And so a lot of NASA's docket after this seems to currently be focused on the moons. There's the Europa Clipper, which is swiftly in the planning stages right now. There are proposals out there for studying the volcanoes of Io, and just some of the other possibilities with the Jupiter system. So I think we have our eye firmly on it. And I think it'll be a few more years before we know if there's going to be a flagship mission quite like this one. Although I don't know if NASA wants to have this nail biter every time, swooping in, seeing if their craft survives, putting it in harm's way, having its camera burn out after 7 or 8 orbits, possibly. This is a lot more daring a mission than we typically see. And so, it's kind of exciting what the future could hold, because that could be some really cool in-depth exploration of the moons, and that could be, even more in-depth exploration of Jupiter itself. It would be great if we could get something that was a more sophisticated version of the Galileo atmospheric probe that was dropped into the planet in 1995, and which we're still kind of scratching our heads to determine what was going on there. There was a recent study that came out that suggested that it may have just fallen into a giant solid pillar of ammonia that exists within, that are structures that exist within, the quite thick clouds of Jupiter.
There's so much going on, and the more we see, the more we know there's just so much going on underneath the surface. And I think we just got information that NASA has just announced that they've just about finished up the spin-up part of their maneuver and are about 15 to 20 minutes away from the start of the burn, the slowing down, using a lot of that fuel to slow down this spacecraft. And so as we're getting into this really pivotal point of its entry into its orbit around Jupiter, do you think there are certain things that are on the top priority of things to be concerned about, particular dangers that may be made available for this telescope as it starts to make its way closer to Jupiter?
Yeah, I mean, I think, of course, they've shut down a lot of the systems going in just to make sure that it doesn't fall into safe mode when it's supposed to do its burn, that something doesn't go wrong in those respects, that it doesn't, use up too much of its energy. There's still obviously going to be some tense moments in here. I think probably the priority is just pulling off the orbital insertion. You don't want to pour this money into this craft, be excited to get to Jupiter for, the second in-depth time ever, and suddenly find that you're flying right past it really fast. And, you miss your target. This isn't like some of the other missions that, there was recently the Japanese Venus probe that was able to wait 5 years and go back to Venus and successfully enter an orbit. This is kind of a one and done. They've really got to enter this orbit, and then from there they just have to make the craft survive over the next 20 months of the mission.
Which will, be quite a difficult task considering everything that's around Jupiter and going on there. And I believe NASA was mentioning that we might know later into the night, maybe around midnight, 12:30 a.m. Eastern time, whether or not things have been successful. I think there's a strong amount of optimism. So I don't think people have to worry too much about this. And
it's
so
it's still going to be a nail biter to the end. And, here's hoping that it also doesn't have some of the problems that other visits to Jupiter have had. There was Pioneer when it first flew by. They hadn't quite anticipated the strength of the radiation that Juno will be studying in depth, and some of its instruments were damaged as a result. And with the Galileo mission, famously their long band antenna did not deploy correctly. And so they actually were hobbled a little bit into having slower transmission rates of the data they were returning. And I think that there's been a lot of lessons learned in the interim there, but then it's going to be the matter of getting everything back up online and actually beginning the process of studying this. The orbit's the big feat, but then it's going to be, now that everybody can breathe, get that craft up and running and ready.
Yeah, I cannot wait for the science that's going to come out of this mission. And actually, if our viewers wanted to learn more about the Juno mission, what's going to be going on there, it's going to be in this month's Astronomy magazine issue, right?
Yes.
It's the cover story?
It's the cover story. It's, quite a tremendous article. I think, I realize that not everybody may be a print reader anymore, but you should go out and get a copy of this. It's just a quite phenomenal story. And we're also having a little bit of coverage on the website as well.
And it's such an amazing event. So I'm sure there's just a wealth of information that you can find really here. And John, thank you so much for telling us a little bit about it. It's certainly the tip of the iceberg here. Thank you very much for joining us, and really an exciting night for planetary science and exploration here.
Yeah, anytime. Thank you so much for having me.
Oh, absolutely. And so we've been learning a lot throughout this show. There's so much going on. And really, just through the course of history, Jupiter is one of the most prominent objects that we see in our sky, extremely bright. And we've been observing its motions for hundreds and hundreds of years. And now we're getting closer and closer to it, and we've actually, with our Slooh scopes, been able to see spacecraft as they're heading on their way to Jupiter. And now, in these coming years, we're going to start seeing from the eyes of a spacecraft orbiting so very close to Jupiter, already right in the midst of its magnetic field and all of the sort of the dangers that being near to Jupiter can cause. And so this is really going to be an exciting time for planetary science. We're just getting started here, just getting into orbit. And there's a bright future, I think, that's quite ahead of us. So thank you very much for joining us here tonight for this live Slooh show all about Juno arriving at Jupiter. And if you want to know more about some Slooh stuff that's coming up, just tomorrow we have a couple great shows. Of course, Bob Berman is going to be on Tuesdays, as he always is, as well as myself. I'm going to be host of Down to Earth, and I'm going to be talking a little bit about a compare and contrast. So we talked about Jupiter and missions that are heading to Jupiter, but what about some of the stuff we've been doing on a terrestrial planet close by? What about the stuff going on with Mars? So if either of those interest you, you're welcome to watch them on slooh.com, because we're always around and we're always getting new stuff out. So thank you again so much for joining us. Have a great rest of your night. Great 4th of July, and it's going to be a lot of fun. At Jupiter.